Hello all. So this is a class 10 physics question for CBSE, comes under the chapter light for spherical mirrors. This is a concave mirror question. So it's given that the focal length is 20 centimeters. By sign convention we see that f is equal to minus 20 centimeter. The object height is given. Image distance is 30 centimeters, and we've got to find object distance and the size of the image. Now in the absence of any other detail, we cannot readily make out if this is going to be a real image or a virtual image, and therefore we have to solve for two cases, assuming in case 1 that it is a real image and in case 2 as a virtual image. So let's get going. In this case we have, if we consider a real image, and that's going to be case 1, let's consider virtual image as case 2. So in this case we see that the image distance is going to be minus 30 centimeter. Concave mirror, real image, by sign convention v will be minus, and from what we already have for f, which is minus 20 centimeter, we can apply the mirror formula to find u. So by mirror formula we know 1 by v plus 1 by u is equal to 1 by f, and that gets us 1 by u is equal to 1 by f minus 1 by v. Let's solve for u now. So 1 by u comes to minus 1 by 20 minus of minus 30, and this gets us 1 by u is equal to minus 1 by 20 plus 1 by 30. Let's solve for u. So in this case 1 by u comes to, therefore u comes to minus 60 centimeters. We will review this in a while after we have completed the second part of the case, which is second part of the question, which is case 2, virtual image. Now for the virtual image we would have v is equal to plus 30 centimeters, because in the case of concave mirror, when the image formed is virtual, by sign convention image distance is plus 30 centimeter. So now the focal length will be minus 20 centimeters irrespective of what. And now let's find by mirror formula. Let us apply the formula. 1 by v plus 1 by u gives us 1 by f, and therefore 1 by u would come to 1 by f minus 1 by u, and that would get us so if you solve for u, here we get the LCM as this, and eventually you get to u is equal to minus 60 by 5, and that gets us u is equal to minus 12 centimeter. So we get the object distance. What is interesting to note is we don't have to write this as part of the solution, but we can do our personal review, a revision I would say, of what we have just completed. So in the case of real image, we know from our understanding of ray diagram that a concave mirror forms a real image only when the object lies beyond the focus. So object distance 60 centimeter, which is greater than the focal length, complies with that understanding. In the second case, it's a virtual image, and we know that a concave mirror forms a virtual image only when the object is in between the focus and the pole, which means the object distance must be less than the focal length. And the fact that the object distance, which is 12, is less than the focal length, which is 20, it once again complies with our understanding. So an understanding of the ray diagrams helps us to ascertain or check for ourselves as to what we have done is right or maybe not. Now let us do the second part of this question, which is all about finding the height of the image. Now from this detail that we have just found, we are in a position to calculate the magnification. So magnification here is, we know it's minus V by U for a spherical mirror. So in this case, it would come to minus of minus 30 divided by minus 60, and that is eventually going to be minus 1 by 2. We know Hi by Ho is equal to magnification, and that is equal to minus 1 by 2. So if you substitute the value of Ho, which is 4, it's given, we get the image height, which comes to minus 2 centimeters. Now the magnification is minus 1 by 2, and that gets us to calculate Hi. Once again, the sign minus, it complies with our understanding of ray diagrams and sign convention. Real images are inverted and the height would show minus. Let us now do the same over here for the case of the virtual image. We are now looking at a virtual image. So in this case, we have M again comes as minus V by U for spherical mirrors, and in this case it would come to minus of 30 divided by minus of 12, and that comes to plus 2.5. Again, this is a virtual image, so magnification as plus is in compliance with our understanding, with our prior knowledge. So that gets us Hi by Ho is equal to 2.5, and therefore Hi is equal to 4 into 2.5, that comes to 10 centimeter. And the fact that this is plus 10, we are again good with the solution. It complies with our understanding that virtual images, because they're erect, by sign convention it would have a positive value. So all in all, a solution marrying, I would say, or combined with our understanding or knowledge of ray diagram helps us ascertain as to what we are finding, and if what we are finding is right or maybe not. Thanks for watching.